Okay, we are going to test the remote control. I installed all the servos shown in the previous pictures, and now let's see how they function. We have on the top here the servo for the steam whistle. In the back there's another one triggering the valve here for the steam pump. Then we have the main valve on this side. This one, which triggers both cylinders, and we have another servo going, or a couple of servos, which triggers the vulture gears of both engine units here and on the front. They are coupled and they are parallel connected. New is also I have a voltage display to show me if there's enough power on the side of the receiver. The transmitter is a spectrum again. Let's start here with the steam whistle. Also, this steam whistle is now a bit more optimized. Listen to the sound. The steam pump. The steam pump is also working very nicely. Now the next test will be under real heat conditions. So the zeros for the vulture gear are now adjusted and a bit more optimized using the trick with the voltage meter, and now I show how it starts in one direction, then I turn it in the other way around, and then it goes in the other direction. Once again, forward. So a few words to the situation where the remote control shows a failure. If the transmission of the signal from the transmitter to the receiver fails, or the akku is empty, there's a problem of the signal transduction or transmission. And what happens is, or what may happen is, that the locomotive has still full speed running over the tracks under steam, and if the remote control fails, then it could increase even the speed and could fall from the track down to the ground. And in order to prevent this, I installed a Failsafe. I programmed it in my remote control. And that means that whenever the transmission fails, the servo goes to the zero position for the speed control for the main steam valve here in this area. So that means it goes automatically down to zero whenever it loses the signal. And I show you this, how it works. I now start the engine, and then I turn off the signal, and then you will see what happens. Now I start the engine. So the signal just turned off, and also as soon as the signal goes away, it stops. The zero goes to the position 0. Now I turn it on again. And it's running again. So an advantage of this voltage meter is, as soon the servo, one of the servos, is at the in a uncomfortable position, it stresses the engine and it draws a lot of current. You can see it here. It turns then red, the LED, and that means it is over the maximum position and is under stress. And if the mechanics are under stress, the motor draws more current, and then the voltage drops for a short time. So it is possible with this voltage meter to adjust the right servo position so that the whole system is not under tension, the mechanics, and then you draw not too much current. And this is a nice way to adjust the optimal positions of all servos. So the LED should be always green, and this is then comfortable for the whole system. I will also now wrap all these wires in a black silicone tube, so that they are protected from the heat from the side. This will be done later. So you see the receiver position. And you see the heat shield there. This is the metal sheet, and the receivers on the right side, separated from the fire room. So the optimization is done, and thank you for your attention.